Yes. Okay. So it's being recorded right now. Thank you for the reminder, Dr. Nana.
We will start at 3.
Sorry? Yeah, in 3 minutes.
Start at 2:30, sorry.
2:30. Yeah. I think I'm also having some bandwidth issues. And my
Okay.
daughter's having some online classes at the moment. So
Okay.
I think you can remain
maybe,
invisible for some time.
yeah,
Yeah.
you can hear my
Your
voice, right?
voice, yeah. Okay, I think we can begin. Hello and welcome to webinar TVET, digitalization of TVET, creating the new normal or living with the new normal. This is a webinar. This is the third series that we have sort of organized. And the whole purpose of it is, well, since the COVID, we are trying to find and come up with new ways and new pedagogies and practices our lecturers and our students to abide by so that life in the education world can still move on. So this is the third series that we have had for 2020. And today, this is the second day. And the slot that you're going to follow next is a very special slot. We brought all the way from Mumbai, India. We have heard very much about the virtual sorry, we have heard very much about the virtual labs. I've seen a couple of virtual labs experiments. We are all very excited. So we have invited Dr. Anita, who is the project manager, to be with us to give us a more in-depth explanation of what it is and how we can use them, taking into consideration that within the TVET world, we need lots and lots of hands-on, and it has been jeopardized with this online situation. So with that, I would like to pass this on to Dr. Uma to proceed. All yours.
Right. Thank you, Dr. Nana. Good afternoon, everyone. So I'm Dr. Uma, and today's session is specially curated because throughout our first webinar session, there were many questions on how do we actually bring our labs to the students, especially when we are doing remote teaching right now. So what I managed to do was to do some search online, and I discovered about the amazing work that Mr. Pushpadeep Mishra, who's the project manager of Virtual Labs, which is MRHD Government of India initiative. And also I discovered that Dr. Anita S. Divagar from IIT Bombay actually worked on her PhD thesis on development of guidelines for teaching and learning with virtual laboratories in engineering education. So I was like thinking, okay, they might have some solutions on how we can actually bring a virtual lab to the students. So for those of you who are not familiar with it, so a virtual lab is like a simulation on screen on what is about experiments that are actually performed in real labs. Okay, so without let me introduce Dr. Anita first. So she has her PhD in educational technology from Indian Institute of Technology, IIT Bombay, under the guidance of Professor Santosh Noronha. So she has developed a tool to help users to design effective virtual lab experiments. Okay, and she'll be presenting on behalf of Mr. Pushpadeep, who's the manager of virtual labs. So she will be giving the introduction of what virtual labs are, and then how she's going to use her tool to help lecturers to design your own virtual experiments. So without further ado, I'll pass the slot to Dr. Anita.
Yeah, so
Dr.
good
Anita?
afternoon, everyone. Good afternoon, everyone. Thank you, Dr. Nana and Dr. Umavati for considering me for this particular session. Thank you, Ministry of Higher Education Malaysia, for this wonderful initiative to help teachers in this particular pandemic situation and not to hinder the learning that happens in the laboratories by having this particular session on virtual laboratories. So I think now I would like to share my screen so that I can start the presentation. And visible?
Yes, it is visible.
Yeah. Okay, so this particular presentation I am doing on behalf of Professor Santosh Narona, who is the principal investigator of this Virtual Labs project, which is a MHRD Government of India initiative. And he is my supervisor for the PhD thesis. Now, going back to why do we need a lab? Okay, so basically there are two reasons. One, interactively test a theoretical concept, and second, to become familiar with the real world hardware. Now, when we talk about the concepts, now there are different levels at which we can have the learning of the students. I think most of you might be familiar with the Bloom's taxonomy, which classifies the learning objectives at 6 different levels. So at the bottom, remembering, that is recall the unknown concepts. Then second level is understanding. Third is applying. Then fourth is analyzing. Then fifth is the evaluating, and the last, that is the creating. And as you go higher up in the hierarchy of this learning objectives, the amount of thinking and the amount of learning that takes place, it is increasing in the increasing order. Okay, so this is in the increasing level of difficulty. So similarly, the virtual laboratories, or for that matter, any laboratory experiment, can be designed to target the learning at any of these levels, or maybe one or two or more levels. Okay, so depending on how the experiment has been designed, the learning objective can be accordingly achieved. Now, why actually we thought of this virtual laboratories? Because in the physical laboratories, there is always no shortage of equipment. Then there is limited access. For example, if you have a physical lab in your institute, the students are given access to the laboratory work, say for example, 2 hours in a day or 4 hours in a day. And if they are not able to complete their particular experiment or particular practical work in that duration, naturally they are not given access after that. So maybe in a week they come to the lab for a particular course, say 2 hours or at the most 3 to 4 hours. Whereas in the virtual labs, it is possible to have access 24/7. Similarly, most of the equipment that is required, it is very expensive. For example, in chemical engineering, we need lot of reagents, which are again expensive, and obviously it can be sometimes hazardous, right? So these are some of the problems which students and teachers face while they are working in the physical labs. So the basic idea of a virtual lab is that it is a physical lab or a simulator located remotely, is accessed to the internet by several remote users. Okay, so this really gives an idea of what are the 3 different types of virtual labs. So the first type of virtual lab, that is modeling and simulation lab. So here the students, they learn through interactive animations. So there are animations or simulations on screen, and then interactive, they have interactions inbuilt into that particular simulation, and students learning happen through these interactions. So naturally the level learning that can happen depends on the level of these interactivities that have been designed. Then the second type of virtual labs are the measurement based labs. So here the learning, it happens through simulated data sets from the actual physical experiment. So we have performed the experiment in the physical lab. We know that, okay, if this is the input that is given to the particular set of equipment, this is the output that should be obtained. And these are the different plots or graphs that can be obtained from that particular physical equipment or the set of equipment. Then this type of labs, they simulate everything, that is The students are actually able to collect the data, analyze the data, and carry out this experimentation using these measurement based labs. So here the data is involved, which is actually the data obtained from the actual physical labs. The third type of lab, that is a remote triggered lab. So here the learning happens through remotely accessible labs. So basically there were some shortcomings in the learnings in these two types of lab, that is simulation and measurement based labs, and that is why people thought of these remote triggered labs. For example, in these two types of labs, every time the student logs in, or every time the student performs a particular experiment, he is going to get something which is ideal situation. Whereas when the student goes to a physical lab, naturally nothing is ideal. He has to face a real world. So there are some problems which do not happen in these two types of labs, which can occur in the actual lab. So that is why in the remote triggered lab, the actual lab, that is a physical lab, the hardware is located in a central place. For example, in say a laboratory in the IIT Bombay campus, and then students may be located anywhere in the world, and they can access this hardware remotely through their maybe desktop or laptop, and carry out experiment on the actual hardware. So naturally, when they are dealing with the actual hardware, whatever problems they face in the physical lab, they are likely to get in this remote triggered lab. So the learning happens as if it is in the actual physical lab. So these are the three types of virtual labs. Slide, if you see, this shows actually the first two types of lab, that is the simulation labs and the this modulated lab. So here, if you see, this is just like and the beauty of these simulated labs is that the simulator gives the feeling to a student as if he is working with the actual hardware. So if you see here, this is the actual physical equipment which has been simulated on screen of the computer, and the student can interactively, he can change the positions, he can switch on something, just like in the physical labs. Here, if you see this in the second picture here, if you see the student, this is a hand which is, so actual in the chemical lab, whatever the student does, he does it sitting at home or at any place, and playing around with the equipment through his computer. So these are all simulations. Similarly, this is the third picture which shows the flow through the Venturi. So here also, this can be, opened and closed. These valves can be opened and closed with the clicks of the mouse or movements of the mouse, and so on. They can, add the readings. They can collect the experimental data. They can, so all this is like, simulated on the screen of the computer. And so, just like they are doing the actual experiment. And this is available 24/7. They can do it. It is self-placed. They can learn at their own pace. It is not like, in the physical lab where we are asking them to complete it in 2 hours or so on. So this is the, advantage of these virtual labs. In just like in case of the physical lab, we provide them a lab manual. So here also it is like, the virtual lab has got these different tabs. So the student can have, so first, that is the aim, then pre-test, theory, simulator, procedure, post-test, review questions, reference, and feedback. So these are the various tabs that are provided any of the virtual lab, and these mostly it is standardized. So most of the virtual labs will have these different tabs. So pre-test is basically, so theory is basically the theoretical concept, or through this particular experiment, what is the theory that is getting covered, that will be present. Then simulator is basically the place where the students will actually play around with the simulated hardware. Then a step-by-step procedure is defined here. Then there are some post-test questions, some references, and also there is a feedback that the student can give. So this particular slide, it shows like, how the test is. So it's a multiple choice question type of a test. and it is related to the particular experiment. So student can click on these and verify whether he has given, and when he clicks on the submit button, he will get to know like which of these answers which he has given are correct and which of the answers he has given are wrong. So it is like a self evaluation of the student. And then this is the simulator. So here in the simulator, just like in the physical, he can, this is the simulator for the flow measurement by Venturi meter and Orifice meter. So here, this is he can start by clicking the mouse, start, reset. When he starts this stopwatch, naturally this animation, it starts, and this liquid starts falling. And this will give you in this particular text box, the volume that is collected here, it is displayed. Then after that, he can measure these levels here, this level and this level, and he has to now here it is interactivity has been provided to the student. So looking at these two levels, he has to enter the observed pressure drop. So he is, interactively doing the work in the, just like in the physical lab. Now this is another lab, which is a computer graphics lab. So this has been contributed by PVG College of Engineering. So again, as I mentioned, there are these different tabs available here. And then this is the simulation of the, so the experiment DDA line drawing algorithm. So they play around with this and they can see the actual coordinates of these lines. So if they, again, these, there are colored visuals which define that green means it is correctly plotted, red is wrong, and black is the correct but not plotted. And similarly, we have this multiple choice post-test questions. So basically, if you see this, the simulation labs, they are a complete learning management system. So you can know the student, it is a self-paced, self-learning management system. So, and it can be integrated into the curriculum. This I will be covering in my particular talk later. And the beauty of this, it is free, absolutely free. Any student anywhere can just click on that particular lab and start using the lab. He just needs to have a laptop or desktop and a good internet connection. Yes, he has to pay for the internet connection that is there. That is the only amount he has to spend. And then efficient and useful teaching aid. Okay, so any questions so far, sir, or should I go ahead?
Carry on, Dr. Atta. There are no questions at the moment.
Oh,
so this is the slide that Mr. Pushpadeep prepared, right?
yes, yes, yes.
So yeah, I think we can start with yours.
So these are the benefits from the student's point of view, specifically in the current situation, like they find it motivational, physical distance no longer limits the learning process. And all these experiments, they have gone through a rigorous review process wherein, the experiments have been designed and implemented with a lot of care and review. So there is a accuracy and no reliability involved in that. They can learn self-evaluation. And these are the various institutes of India which have contributed in the initial part of the project. And in the particular project we would like to cover. So this is the virtual labs portal of the centralized virtual labs portal, and this is the portal of IIT Bombay. Initially, there were 9 disciplines which were covered, 114 labs and 1200 experiments. This was in the year 2008-9 and so on. Labs in the country as a whole. If you see, it's a pan-India process that is happening here. And this is the virtual labs outreach portal. That is how many institutes are using the labs. Here we get, a complete analytics of how many students are using, how many teachers are conducting workshops. So till now, if you see there is an exponential increase in the number of usage. So this is the total usage. That means the experiment that have been performed using the virtual lab. So around 8 lakh experiments have been performed. So basically we have 20, when it started, we had just 20 nodal centers, and now we are around 700, and with more than 20 lakh usage and 8 lakh experiments that have been performed. More than 500 workshops have been conducted. So, of how you can become a nodal center of IIT Bombay. So colleges are invited to regional workshop. They submit an expression of interest. A nodal coordinator is nominated, and then there are workshops which are conducted for the students. Then nodal centers reach out to neighboring colleges, and then periodic coordinator meetings are held and performance is reviewed. So this is the rollout. And then now currently we are in this development phase. So here the people can participate in boot camps and workshops to develop their own content. So here at this point, people have started contributing to the development as well. So initially it was just using of the virtual labs. Now they are contributing to the design and development of virtual labs. So student run projects are there on content development, and then also IIT Bombay provides student internships. Interns of our previous internship program. And this is the portal which is used for the virtual labs development. So this is vlabs.iitb.ac.in/vlabs-dev. So this is the VLabs community portal. So currently, if you see, there are so many universities that are, part of this community, around 789 universities all over India that are part of this VLabs development community. And now why this was felt, or why we went on for this, because initially there were only 1200 and there was syllabus gap, like the curriculum of each city, there are some differences. Although it is the same country, there are some slight differences in the curriculum, and so naturally some some experiments are there present in the virtual labs, but some were not present. So that is why we felt that there is a need to fill this particular gap, and so this community was developed. So it proposed the concept of community based virtual labs development. And so many institutes enrolled in this, and 300 experiments have been developed by the community so far as of today. This is the list of the number of experiments and the colleges and the faculty who have contributed to this particular development of virtual labs. He also has conducted many virtual labs workshops for the development process. So these, again, if you click on these, you will get all the details of what all were the workshops that were conducted, what was the content, and what were the labs that were developed as part of these workshops. Along with the workshops, we also carry out, these boot camps. So this is the picture of the first boot camp that was conducted at Marwadi University. There are more than 100 participants, including the faculty and students, and a lot of experiments were designed and developed. So this boot camp is basically a 1 week rigorous training which goes on throughout the day, and starting from scratch. By the end of the workshop, students have along with the faculty, we form groups of 4 to 5 people with one faculty member and 4 or 5 students. So together they start from scratch, from the concept to the complete design and development of the experiment, a virtual lab experiment. So this is the again a bootcamp 2.0, 3.0. This was in Aurangabad in Maharashtra state, and this is a bootathon. So basically we had a competition of the virtual lab development. So bootathon was organized recently in REC Banda, So this is a picture where, students again work day in, day come up with their own virtual lab experiment, and we announce some prizes based on who develops or the quality and other aspects of the developed lab. So 3 boot camps and 10 states, 30 institutes were there, 50 faculty and students were trained through the boot camps. So this is the lab development process. So there are 13 steps in the complete lab development process. So new proposal is given, then there is a check. There is the lab development committee to review and approve the proposal. Then the developer proposes the pedagogy. Then there is a review again by 3 reviewers. Then the developer proposes the storyboard. Then again it is reviewed by 3 reviewers. Then he submits the source code, and again the source code is reviewed by reviewers. And then there is a beta hosting for just tasting purpose, and then again it is reviewed by 3 domain reviewers, and then it is finally approved, and then there will be a central hosting of the labs. So for this, basically lot of local funding support is required. Process continues to be refined. So more emphasis on the pre-bootcamp sessions. Certification is given to the developers, and expert review during the bootcamp also is carried out by the expert reviewers. So the long-term goals or benefits is that creation of new simulator labs, obviously creation of new hardware labs as well, and then this also leads to a lot of innovation. So students are learning while they are also creating. So that is the model. Okay, so
Can I
this
ask
is
something?
yeah.
What is the role of the nodal community? Is it the nodal centers? Is
So
it? Yeah.
basically, so I'll just go back to here. Basically, sir, what we do is the any institute who wants to be a part of this virtual labs community. So we have a community of virtual labs. So in this community, there are some institutes who are just using the virtual labs, and some people who are contributing to the development of new virtual labs. Right. So there is an outreach as well as a development. Center concept is basically, suppose in your area there are say 5 or 6 engineering colleges. So you become a nodal center. Now you are responsible for conducting workshops for your institute as well as institutes in and around your region. So you become a part of this IIT Bombay Virtual Labs community. And for that, you just have to, say that, okay, I'm interested in being a nodal center. So there is some formalities that have to be, some form that has to be sent on your behalf. And then you become a part of this community. So your institute now becomes a nodal center. There are some small requirements to be a nodal center, like there should be a computer lab, and one person should be a nodal coordinator. So one person is responsible for taking care of the activities of the nodal center, like conducting workshops for the students, ensuring that the students and the faculty members of all the departments are using the virtual labs, and if they have any issues, these issues get resolved. So all this is the responsibility of the nodal coordinator.
Thank you.
And
I
yeah,
may communicate with you later on
sure, sure.
about the nodal coordinator.
Sure, sir. Yes, sir. So,
Please carry on. Yeah.
so actually, this was the end of the presentation that Pushpadeep has shared on behalf of Professor Norona. So, any questions on this particular thing? If there are there, we can take, or then I will start with my presentation on how we can integrate these labs in the teaching.
Dr. Anita, yes, I think you can proceed to your presentation.
Okay.
on how to integrate virtual labs in teaching and learning.
Yeah, yeah. Okay, so now that you know, like, what is a virtual lab and what are the benefits of the virtual lab, what are the different types of virtual labs, I would like to take you through, how you can use these virtual labs. So this is the outline of my presentation. So benefits of using virtual labs. We will see some of the important features of virtual labs and integration of virtual labs in your online teaching and effective virtual lab experiment. So how we can design and develop effective experiments. So these are the learning objectives of my session. So faculty will be able to perform experiment, use virtual labs in online teaching, describe the features and the 5-step scientific experiment design process. So, so is it possible to have some interactivity here, Dr. Umavati?
Yes,
With the
please go ahead.
participants.
Yeah,
So this is
yes,
like, I would like to question here to the participants.
sure. Just give us the Mentimeter code and then we
Yeah,
will get
yeah,
them to
yeah.
do that. Yes, I'm sure they'll be waiting to participate.
Yeah, so this is the first question. So I just want to know, like, so the branch and domain of the participants. So I've just specified a few domains. Are they able to see this question?
Yes, so let's just wait for the responses.
I think there is some. I just go back. They just have to. Okay, we are getting the responses.
Yeah.
Okay. Okay, so I can see that participants are from different domains like electronics, civil, computer, IT, basic sciences, others, and so on. Okay. Okay. Okay, so as you can see, the participants are from different domains. So now I will go to the presentation. So this is the next question. You can just enter your response here so that I understand like what is it that you expect from the session. Maybe I should have given a multiple choice here.
No, I think this is a good way to actually gather information as long
Yeah,
as it's open-ended like this.
yeah. Okay, okay. So we are getting the response. Yeah.
Yeah.
Okay. Okay, interesting ways to teach through online classes. Yeah, I think this point I am covering can help me in formatting assessment. Okay, set up a virtual laboratory. Okay. 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 Okay, so thank you all the participants for your helps me in, I believe that the presentation should be able to cover most of these aspects of learning that you have mentioned here. So now see, in the previous presentation, I have explained to you the three types of virtual labs, right? Now, sometimes, there is still a confusion regarding what is the difference between a virtual lab and a simulation of scientific phenomena. So I would like to just clarify. So if you see this particular picture here, so this is a simulation which gives that the resistance, it depends on the resistivity, length of the material and the cross-section area. And these three values the students can manipulate. There are sliders here and the students can change this, and accordingly the resistance value will change. So this is basically a very simple simulation of a scientific phenomena. Now next picture again, this is again like I said, there are a simulation of electronic devices and circuits lab. So here there are all types of components are there, like there are linear components, there are non-linear components, there are all the equipment that are there, the supplies, the meters and so on, oscilloscopes and so on. So this is again a simulation of the electronic devices and circuits. Now to virtual lab, okay, now can you call these two simulations are virtual labs? No. To call necessary is that obvious virtual lab, the simulator should have all the components, devices, equipment, so that the students can play around, select from many, use them, operate them and so on, just like the physical lab. And then there should be a well-designed experiment that can be performed using this simulator. Then together we can say that this is a virtual lab experiment. And then many such together experiments together, we can call it as a virtual lab, right? So now what I want, so these are the links that are there which I have tasted. and all these links are currently working. And because some of the virtual labs, there are some issues, so I just identified those labs yesterday night which are not giving any issues or any problems. And I'll be sharing these links in the chat window so that you can go to these particular virtual lab links and perform the experiment. Now, these are the virtual labs. Now, the future trends in virtual labs is in virtual reality labs and augmented reality labs. Now, we have seen these three types of labs, that is the simulation, data labs, and the remote triggered labs. But now in future, people are working in this virtual labs, and they are having these virtual reality labs as well as the augmented reality labs. So these are currently the trends that are being followed internationally. So we have seen that in our country, we have currently a lot of 1800 experiments, simulation and remote triggered and measurement lab. But in the international scenario, the labs are being developed as virtual reality labs and the augmented reality labs. So again, these links, I'll be sharing it so that the participants can go through these links and get a feel of all these types of labs. And also these are some YouTube videos which you can go through and get a feel of these virtual reality and the augmented reality labs. And these are the companies which are involved in designing of these labs, and are also making the tools available for designing of these so Unity 3D, Unreal Engine, 3ds Max and Maya, Blender, SketchUp. So these are some of the tools which can be used for coming up with the futuristic virtual reality and augmented reality labs. Okay, so now I think time for all of you to have an experience of the virtual lab, actually hands-on experience. So what I will do now is, in the chat window, I will share these the links, and they are all available. You can just click on these links and so I have shared with you the links of the labs, some of the labs. So I've identified the labs from different domains like computer science, electronics, and so on. Now, these are again the labs from different domains. Which domain you belong to, you can just click on the, or maybe you can go to this vlabs.iitb.ac.in portal, and I'll just also give a demo. So this is the VLabs IIT Bombay portal, and when you click on this tab, that is Labs tab, so these are the various domains in which these labs are available. Electronics and communication, computer science, electrical, and so on. So when you click on, say, the electron, so again in this, these are the various courses for these for which these labs are available. Okay, so I will click on this digital logic design lab. Okay, so if you see, there is an introduction, list of experiments, target or
we seem to have lost you, Dr. Anita. Yeah, there might be some problem with your site.
Yeah, we have lost her, I think. I'll try to contact her on WhatsApp and ask her if everything is okay.
Okay, thank you.
Well, in the meantime, I think we can ask the attendees to actually go to the website and have a look at the, uh, at the different virtual labs available.
What is the URL again? Is it the one up there?
I've typed it onto the chat as well.
All right, okay.
relabs.iitb.in. Yeah, I've typed it into the chat.
Hello.
Yes, you're back.
Yes, okay, she's back.
Oh, I thought like to. Okay, so
You can
am I
carry on,
visible
Dr.
and
Mehta.
audible now? Okay, okay. So I was just giving a demo of this particular lab. That is so click on this, you will get the list of all the experiments that are there in this particular lab. So there is adder, multiple decoder, ALU, and so on. So you can just click on any one of this particular experiment. Get to see again theory, objective, procedure, equipment, and so on. So theory, when you click, you get the complete theoretical aspect of that particular experiment. Then what is the objective of this experiment? Then there is a complete manual for the experiment and a step-by-step process as to how you should, use this simulator, how you can carry out the experiment. Then there are prerequisites, and then you have to click here to perform the experiment. So you click on any of these links, you will get the same tabs there. So now we will go some other, maybe say computer science laboratory, say problem solving laboratory. So here again, there is an introduction and so on, and the list of experiments. So you can go to the numerical representation. So in the numerical representation, again, there is an introduction. Then there is a theory what the numerical representation means, the objective of this particular experiment, and then the actual experiment. So here when you click, actually you go to the simulator. So here, you can choose a file to load, or you can write here your code, you can edit your code and so on. Then when you click on the compile button, this particular code is compiled, and then you can click on the run button to run your code, or directly you can choose a file and upload it. So this is for the computer science lab. So there are a lot of courses for which the computer science and engineering labs are there. If you go to the chemical, there is this chemical engineering lab. Again, these are the experiments. I think this is what I was showing This is a simulator that I demonstrated in the in the presentation. So Venturi meter and Orifice meter.
Yeah.
Similarly, if you go to this particular website, you will get the domains first. So you have to click on your domain, whatever domains, say physical sciences. Again, these are the experiments. Then you have to click on the particular course, say molecular interaction lab, list of experiments, and then click on the experiment that you want to perform, and you will get all the details there.
Right.
So I'll just maybe, do we have time or?
Yes, yes, we do.
So should I give them 5 minutes to explore the labs?
Yes, that'll be great. Okay, so pensyarah-pensyarah boleh cuba virtual labs mengikut bidang masing-masing, boleh explore sendiri, dan kalau ada apa-apa persoalan boleh tanya. Ya. So we'll give them about
Dr. Yeah, Dr.
Yeah.
Most of these experiments,
Yeah.
sorry, most of these experiments, are they in the degree level or in the diploma level? How do we differentiate?
Actually, if you feel, if you can just share, the curriculum, because I am not sure what is the curriculum of your, engineering and diploma. Because here, some of the experiments are at, means even the diploma students can perform, and some of the experiments are like targeted at degree level. So it's not like that the diploma students will find it very difficult or anything. Or maybe some of the experiments they may find it difficult. So if you can share the curriculum, I'll be able to exactly share that, okay, for this course, these experiments students can perform, or for this course, they might find it difficult. So I will be sharing with you a list of complete, I have a complete list of experiments that are present in all the domains. So I can share with you that particular list, and then you can see whatever are the experiments that the students in your curriculum they have to perform, and accordingly then they can go ahead and carry out the experiments. The faculty can identify that, okay, out of these means in my curriculum these experiments can be performed. So students,
Dr. Anita, will you be sharing with us
yes,
the guidelines you have developed? Yeah. So maybe
yes,
we can move on to that. Yeah.
yeah.
Because now they
Okay,
already have
so
the link,
now
so they can,
now
yeah.
in the next part of my presentation, so what I am to share is like how I am integrating the virtual labs currently in my teaching. So so again, I'm just showing a few pictures here to all the participants, that just see the pictures carefully. Okay. Just want all of you to see the picture. So this is the picture of the physical lab. Yes. So you go to the lab, maybe many times first as a teacher or as a faculty or instructor, we carry out the experiment. We see whether everything is working. We arrange for all the equipment, right? Then we provide, then we know maybe we design or come up with the laboratory manual that we have to give to the students, so that when they come to the lab, we know exactly what they are supposed to do, right? Then students, when they come to the lab, we explain to them that, okay, this is the equipment that you are going to use, and this is say a multimeter, this is a CRO. So first we just explain to them like what are all the things in the lab. Then times we give them a demo, or we perform the experiment, they observe it, right? And then they start actually doing the experiment, and if they have some difficulties, then they call us, and we try to find out, say, so they have made the connections, the students have made the connections. in the physical lab, but there are some issues, so we are trying to resolve the issue here. And they carry out the data collection, the the experiments, then they graphs and so on. So they do it on their own, say either individually or they do it in groups, right? And
No,
all this
can I just ask a question? Most of these experiments that we have shown, as far as the virtual labs and IITT is concerned, are they more for the cognitive or are they more for the psychomotor?
They virtual labs. Yeah, that is why, see, it the simulation remote triggered labs, they are good for the cognitive domain, but this psychomotor domain was definitely lacking, which is a very important skill that the students need to develop. So that is why internationally now people have started looking at these augmented reality and the virtual reality labs. So in the augmented reality labs, if you see, basically it's like you are actually doing it, but it's not a actual, it's like a, means you are in a physical space which appears like a lab, but everything is augmented in that physical space. So you are doing all the actions that you do in the physical lab without any danger of causing any harms. Like, so it's, those are the, I would say these are the futuristic labs, and this is the, future of virtual labs. Yeah, which can take care of all the aspects of learning.
Have both of them side by side so that the students can master the cognitive skills and then later on the psychomotor skills. So everything begins with the cognitive skills, and then only then will they follow into the psychomotor skills, right?
Right. Yeah. So as I was saying, so these are the various, activities that we do. So in the physical lab, so what the teacher does, decision regarding which experiment to be conducted, prepare the equipment on the respective table, verify their connections, whether we are getting the correct results, monitor the progress of the students, answer to queries raised by them, and grade the experiment. And then obviously maintain discipline and proper environment. So these are what the roles of a teacher when we go in the physical labs. What are the roles of the students? So what the students do, they go to the lab, a particular table where the experiment is to be performed. They assemble all the equipment, they read and understand the procedure, make the connections, collect the graphs from the data, obtain the results, get the results verified by the teacher, draw conclusions, then ask questions if they are stuck somewhere. Obviously, they also have to maintain discipline. They carry out teamwork and discuss with the peers, right? So now we will see how, you can, now that you are stuck at home, students are stuck at home. So just one question, do you think all these activities can be conducted using virtual labs? Maybe you can just share in the chat window now the answers. I'll just have a look at the chat window. So do you think that all these activities, like I mentioned here, so the student activities and the teacher activities, so do you think that these can be done in the virtual labs? So you can just answer a yes or a no, so that so
I think they're still looking at it, so give them time. But I've seen it, and I think it can be applied. But then again, as far as the cognitive process is concerned, I think it's very applicable if the experiments are matched with the curriculum, of course.
Yes, yes, yes. Right, right.
And,
So,
you were saying that this is all on an LMS. So if I want my students to go and experiment, do I just give the link, or do I, as
yeah,
educator, have got to create a class and everybody goes in? How do
yeah,
we
yeah.
do this?
So actually, I was just going to share that in my what I am doing. See, there are ways in which can do, right? So as I said, these are the activities that we do. So basically, these four things, that is, decision which experiment. So you can just share the link with the students. Okay, today in class, we are online class, we are going to perform this particular experiment, right? So share the link with the students, and everything, right? The equipment is there, everything, the lab manual, everything is there in the virtual lab experiment, as I have demonstrated. So they just need to go to that particular link. Okay. And if you want to give a demo, there are also demo videos that are present in some of the virtual labs. So you can just ask the students before your session that, okay, go to this particular link and see the video and come to the class. Okay. So they already know what is the procedure that they have to follow when they come to your online class. In the current situation, I'm saying, okay. So next, what we can do, this is what I've been doing since the lockdown, or since online. So what I do is, either I take a synchronous class. So what I do is, I a meeting like a Zoom meeting or a Google Meet, I ask all the students to join. So they come in as participants. Okay. And in this Zoom and the Google Meet, the participants can share their screen. So all the students are now, so this is my classroom now. Okay. And initially, I cover some theoretical aspects that I need to cover for a particular topic. For example, say in case of the digital electronics, say today I am going to cover the topic multiplexer. So first, I just share my slides. I discuss that particular topic. I asked them to, I asked them some questions during my teaching, online teaching. And then I share the link in the chat window, just like I did now, and ask the students to perform the experiment. Now, when they are performing the experiment, again, these tools, they also allow the students to share their screens. So I can myself monitor what they are actually doing. So I can say maybe one by one, I can ask the students to share their screen, or other, what I can do is I can ask them to take a screenshot of the experiment that they are doing and share it in this particular, share it as a file. So I get to know that, okay, this particular student is performing this experiment, and what are the readings that he is getting, how far he has reached in that particular experiment. So I get to know, like, how the students are performing in. It's just like, in the physical lab. So just the only difference is that now everything is virtual. All of us are meeting virtually, and the laboratory is also a virtual laboratory. So they are performing the experiment, and in the physical lab, maybe they were doing it in a groups of 4 or 5, but here they are doing it alone, or they are doing it on their own. And as and when they have any problems or anything, they can share in the chat window, and I can see what they are actually doing in this particular virtual lab. So this is what I'm doing for the past 4 5 months. So here again, there is also some of these tools, they have a provision of what is called as a rooms available. So you can form a group of students. Suppose you want to give a activity to the students in a group. So you form different rooms. So you form one room for 4 5 students who are doing one particular experiment, maybe another group of students who are doing another experiment, like we do in the physical lab. and then they can share the screen as a group. So together they can share what they are doing, and you can discuss with them. That is possible. These are the these are the various options that I am using here. So again here, they can either chat with everyone, or they can chat only with the teacher. So this is the advantage of this online teaching, that sometimes in the actual lab, some students, they are shy, they may not ask you questions. But here, because it is like you can have a one-to-one and no one else comes to know what question you have asked, the students are finding it easier to ask the questions to the teacher in the online classes. And you can monitor the students, you can share the feedback, you can have formative assessment. So you can ask a question to a particular student in the chat to only that student and get his answer there. So this is how you can integrate your that is what I have been doing in
I have a
my
question,
online classes. Yes,
Sorry
yes,
to interrupt
yes.
you, Dr. Anita.
No,
I
no,
have a
it's
question.
fine. Yeah, yeah.
Yeah. How many students do you have in your class? The one you're showing us, the Zoom, with the Zoom, and then you have breakout sessions. So how many students do
So,
you have in one session?
so basically, see, our practical, that is laboratory session. So in a class, we have nearly, 60 students and so on. But when they come to the laboratory session, we have around 20 to 25 students. So we carry out these sessions for, say, 20 students, or say in that we can also say 4 groups of 5 students each, or 5 groups of 4 students each, and so on. And accordingly, we can allocate a particular experiment to that group and ask them to perform and share their results online.
How long does it? How long is a session?
So, see, basically performing the experiment in the virtual lab, it takes very less time compared to the physical lab, because in connecting the circuit, they are like same example, if you take the multiplexer. So there, they have to connect the entire they have to take the breadboard, connect the ICs, connect the wires, and do all that connections. So a lot of time gets spent in the connections. Whereas in virtual lab, this time is hardly 5 to 10 minutes. They just have to, go to the, yeah.
So what is
So
the
in half
advantage
an
of that?
hour, in half an hour, you can complete one virtual lab experiment with 4 or 5 groups of students. That is very much possible. So in a day, you can take one experiment, or maybe say 4 or 5 experiments of, say, around 60 to 65 students. That is possible if you spare, say, 1.5 hours, or that way.
Oh, so that
So
means you can actually cover
obviously,
more
again,
when you see them.
Sorry.
So you can cover more in
Yes,
less
yes,
time. You can get more done in lesser time.
yes, yes, yes. Yeah, definitely. And some of the labs, no, they have been, they also have this pre-test and post-test. So there itself, they answer the questions and you ask them, okay, send a screenshot of your answers. Immediately you come to know that, okay, then you can discuss that, okay, this answer is no correct. They may ask you some questions. So in half an hour, no, one experiment you can complete for 20 to 25 students. That is possible. And obviously this is a self learning thing. So if they are not able to understand something when you are online, say maybe there is some network problem, or they don't have that much of bandwidth, or some issues are there, you can always carry this out asynchronously, right? So maybe ask them to perform the experiment and mail you the screenshots of their results. That is also possible. So you are doing all these things offline, grading the experiment offline, and they are performing it on their own and sending you the results. That is also possible. So actually I feel that in this situation, both the things are okay. Like you can either do a synchronous session, lab session, along with your classroom session. So what I normally do is, why we have these laboratory sessions, because whatever theoretical concept or the some principle that we are explaining to the students, we want them to understand the practical aspect of that particular knowledge, right? So if you are integrating your laboratory session also in the classroom session, and we have this facility of the virtual labs, right? So it is, so by the time you cover that topic, your theory as well as the practical, everything is done. And then you can ask them to solve some problems on it. That is possible. Okay, so any other questions?
That's wonderful.
Yeah, I think that sort of fits the bill. I think our lecturers would have to look up the experiments and again try to match it with the curriculum. Maybe maybe the experiment fits. Maybe the experiment is slightly below what is required in virtual labs. So they have to guide and facilitate the students as to how you have to use the labs. I think that might work.
Correct. Yes. Here I would also like to share that, suppose like if some of the experiments are there in curriculum, but they are not there in the virtual labs, the current labs. So I have been carrying out workshops for development of experiments as well. So I'll just share with you this tool that I have developed. So if they want to, design their, suppose you feel that some experiments are not there, which are there in your curriculum, but they are not in the virtual labs that are existing currently. So they can contribute to the virtual lab. And I conduct these sessions, and from lockdown, we have come up with 5 different virtual labs. So one is on fiber optic, one is totally on the topic of oscillate. I'm from electronics domain. So we have developed some excellent virtual labs, and it's not, like you have to spend too much time on that. So this is the 5-step scientific experiment design process. So this also I will share with you all. So how you can design the experiment, and then I also help in the development of that. So I'll share with you this link. So this is actually a process which ensures that the experiment that you are designing and developing is pedagogically sound, okay, and effective. So this is the link that this tool that I have developed. So I'll also.
And this is your PhD work, right, Dr. Anita?
Yeah.
And the Prof. Noron Ha.
Yeah. So this is the 5-step process that the faculty do. So here, we are ensuring that the experiment that is designed is pedagogically sound, and also I some templates for, so once they have designed the experiment, so they just have to click on. So here they can whatever is there, whatever are their thoughts, they can design the experiment accordingly. I'm just typing anything that comes to my mind here. So assessment questions, and once everything they have typed, it creates a
PDF.
So their entire experiment is in the form of a PDF. Now that the PDF is start with the development process. So for the development, basically, I carry out these workshops. So hands-on design and development. So through this, we design the simulators, and with for virtual labs which are open source, so that anyone can access from anywhere, and mostly browser-based simulators. So that you just open the browser, say Mozilla or Chrome or whatever browser you have, and you can start running the experiment. so that you don't need to download any software, and we are not using any proprietary software that you need some license for that, and only then you can, like MATLAB, LabVIEW, because many people have designs with software. But simple, HTML and CSS and JavaScript, we can, yeah.
I see developing the animation as the last input there. Do you have a built-in animation software, or do they have to use, say, for example, I don't know, HTML5, Flash?
HTML software like open source. So I believe in open source software, so that you don't have to spend much on that with your virtual lab, right? So you can use software like Blender, views, and so on. And with simple, HTML and JavaScript, you can come up with.
Do they have to have a certain level of expertise with the animation before joining in?
So what I do normally is I form a group of 4 or 5 people. So in that group, there is one faculty who is the expert of that particular topic for which he wants to design the lab, and 2 students from the same domain, say suppose say mechanical or some other domain, not computer or IT. Because computer and IT students, they are well conversant with the programming and HTML and so on. 2 students who are again, very strong in that particular topic, belonging to the domain, say electronics and so on. And then 2 students from IT or computer branch, so that they know how to write the code. So together, these 5 or 6 people together, they can come up with, they can design and develop and get it, online, a complete virtual lab experiment within, say, 10 to 12 hours of dedicated efforts. So if they together, they spend, say, 10 to 12 hours together, one virtual lab experiment with a good simulator can be easily designed and developed. And it can be hosted on your server somewhere if you wish, like to give access to all the students of your institute that way. That is
Great. That's good news. Thank you very much for sharing that.
Yeah. And I will also like to share another link. Now, see, I have shared with you the link for the virtual labs that we have developed here in our country, but internationally also is being done. So I'll share with you this links from the Global Online Laboratory Consortium, so that you can also have a look at the labs which they have developed, and the students can access those labs. So this is the Labsland portal that I'm sharing here. It's a Labsland portal, and this has been developed and designed by the so this is the Laboratory Consortium. So if you see, the members here are all the top universities throughout the world. So you have University of Technology, Sydney, MIT, US, and then Germany. So all the universities from different countries, they are a part of this consortium, which is a online laboratory consortium. So here again, you can be a part of this consortium, and this is again an international association of online engineering. So they have so currently, because of the pandemic situation, see, all these top universities, they are running online courses on MOOC platforms like edX, Coursera, Udemy, and so on. So in these courses, if they have a laboratory component, then they are opening up their virtual labs to the students of that, those who enroll for or register for that. And many of these courses now, they have made it free of cost because of the situation. So earlier, most of the courses where, you had to pay for it and so on. But even IIT Bombay, we have this IIT X, which is a MOOC platform of IIT Bombay. So there again, when the teacher, is conducting the classes, there are lab components, especially in engineering courses. So the lab component is also taken care of through these courses. Yeah. So.
Thank you very much. That's good to know all how we can all fit into a bigger network.
Yes. So, yeah, so that is what I wanted to share all of you. So thank you for your patient hearing and active participation. So I'll be sharing slides with all of you, so that hope this is just our association, and hope these virtual labs help the students and the teachers of your university. It will be really good if the students don't miss out on the laboratory component, especially in the situation of this lockdown and pandemic. And I would like to wish everyone stay healthy and stay home. Take care of yourself. Yeah.
Okay, thank you very much, Dr. Anita. I think for the past 1.5 hours or almost 2 hours, you have shown us how possible it is to carry on learning in these difficult times, especially with the simulations and the labs that is very much was once in a physical domain. Now it has been transferred into an online domain, and then now everything is online and is free. And I'm also very interested to see how we can participate as a network and how we can develop our own lab experiments, but that will be another session between us. So as far as I'm concerned, thank you very much for presenting this whole virtual labs concept. Again, I congratulate you on having such a platform out there that has helped a lot of people in these difficult times. Thank you very much, Anita. Back to you.
Thank you.
Yeah, back to you, Uma.
Yeah, thank you, Dr. Anita, for the incredible sharing. I think it's really opened the minds, and it's actually answered a few questions that we've been getting. Actually, there's a pattern. Okay, how do I do this thing online? How do I do this thing online? So I hope, Dr. Nana, maybe, we can work together with them and, find ways and, to develop more materials and to make this a more global effort, which will be really beneficial during these unprecedented times. So again, thank you from all of us. Are there any questions? So let's just have a look. Are there any questions in the chat? Okay, so most of them are saying thank you, Dr. Anita. Good sharing. Yes, I think it's really opened our minds, especially the tools. So it's an amazing PhD work you have done there. Generating. I understand that many people. Let's say you have the virtual lab, but how do you do it? How do you use it for your teaching and learning? And you have actually, come up with that system. So it's incredible, right? Thank you so much. So are there any questions? I think I didn't see any questions. Dr. Nana, do you have any questions? Is there anything else, Dr. Anita, would you like to share with us? Last words.
Slides, and if you can share the curriculum maybe with the experiments that are relevant for the curriculum, so that obviously now learners have links to the various labs. They will go through the links and find out the lab that is relevant to them. But in that situation, if anyone needs any help, I can definitely help them out in identifying, and how, if they have any issues, we can sort it out at our end.
Okay, thank you. I think we'll be discussing with the curriculum development division on that matter to see if there are any requirements on creating a very special niche experiments that are suitable with our curriculum. Thank you so much again.
Thank you. On behalf of Professor Norona and Pushpadeep also, They could not join because of the issues. So I would like to thank on their behalf as well. Thank you very much.
Yes, I will definitely send them a thank you email after this
Yeah,
because
sure.
because such short period of time. Actually, just over the weekend we discussed whether it's
Yeah,
possible
yeah,
to have
yeah,
this webinar. So I'm really glad. Um,
yeah.
so to the audience, I hope you'll be able to answer the we have a questionnaire at the end, and then also start looking at your curriculum and identifying which part of the experiments that you would like it to be done in the virtual platform. So at least
Yes.
when we do a needs analysis, whether the potential of this this project, this new project, then at least we will have some ideas already, right, Dr. Nana?
Right.
All right. So thank you again. It's already 4 p.m. Dr. Nana,
Yeah,
this is
yeah.
our third session for today. So tomorrow morning, we'll be having a session at 9 a.m. We'll have international speakers as well. We'll have Daniel Shen from Sokol, Singapore, and Dr. Nora Hussain from Hong Kong University Science and Technology, and also accompanied by two lecturers from College Community Selayang and College Community Bukit Beruang. The topic would be promoting student engagement using soccer. And in the afternoon at 2:30 p.m., we will be having Professor Madhyati S. Dr. Shamsul Nur Azlan bin Muhammad from UITM, who will be sharing on online assessment based on OBE. So we'll see you all tomorrow. Thank you again, everyone.
Thank you. So I'll leave now.
Bye.
All right, thank you so
Thank you.
much, Dr. Anita.
Thank you.
All right, so we'll keep in touch.